Assalamu alaikum and good evening, everyone. Today we are going to attempt IGCSE May-June 2023 and its alternative to practical. So from 2023, whether you do practice uh, IGCSE alternative to practical or O levels, both are exactly on the same pattern and both have exactly the same syllabus, same marking, same kind of a question. And even question from the experimental technique, the second question from the titration, the third question from the salt, the cations and anions, and then the fourth question is the designing of the experiment. Okay, so we'll be starting with one over here. Ethanol can be made by fermentation of sugars found in plants. A byproduct of fermentation is carbon dioxide gas. Okay. The student made some ethanol using the following method. Okay. Cut up some sugar can and crush it. Add hot water to the sugar cane and stir to dissolve the sugar in the sugar cane. Okay. Remove the solids from the mixture to obtain sugar solution. Let the sugar solution cool and then add yeast. Okay. Place the mixture obtained in the apparatus in figure 1.1. Okay. Leave the apparatus until the fermentation is completed. Okay. So if you recall, the lime water is used for the to test carbon dioxide. I think everyone must know this. Name the item of apparatus labeled A in figure 1.1. So I think everyone know that it's called conical flask. Yes, very good, Khatija. Mustafa, you have to write conical flask. Flask is also fine, but the appropriate way is to write conical flask. Explain why hot water rather than cold water is used in step 2. So the basic thing is that we are using the water to dissolve the sugar. So in a hot water, there is a high temperature, so the rate of dissolving becomes faster. So that sugar dissolves faster, right? Name the method used to remove the solids from the mixture in step 3 and draw a diagram to show how this is done. Okay. Name the method used to remove the solids from the mixture in step 3. So yeah, obviously for a solid, we always do filtration. Draw a diagram to show how this is done. So we need to draw the apparatus. We draw the apparatus funnel like this. Is this clear? Okay. Now, B. State why the sugar solution is allowed to cool before the yeast is added in step 4. Okay. For, if you recall, this reaction is called fermentation, where yeast has been added, right, in the glucose. It is for to do fermentation. And if you recall the fermentation, we need the specific temperature, which must be 25 to 35 degrees Celsius. Otherwise, the enzyme in the yeast gets denatured. So the fermentation occurs in temperature range of 25 degrees Celsius to 35 degrees Celsius at higher temperature yeast get denatured. Describe how the appearance of the lime water changes as fermentation takes place. So As fermentation takes place, the carbon dioxide gas has been formed and it turns the lime water milky. So, it is initially colorless and then it turns to milky. Now, describe how the student could tell the fermentation is completed. So, as the carbon dioxide is forming, so it means we are going to observe the bubbles. So, no bubbles form. Indicate that the fermentation is completed. Name the process used to separate ethanol from the mixture obtained by fermentation. So, it's a fractional distillation. Very good, Amma. It's a fractional distillation. Okay. Now, question number 2. A student investigates the reaction between aqueous ammonia and two different aqueous solutions of copper 2 sulfate labeled A and B. Solution A and B have a different concentrations. Okay, both are, copper sulfate and both are having a different concentration. The student does two experiments. Experiment 1, fill burette with the solution A. Run some of a solution A out of the burette so that the level of solution A is on the burette scale and record the initial burette reading. Okay. Use a measuring cylinder to pour 25 centimeter cube of aqueous ammonia into the flask. See, here it's a mistake because whenever we are doing the titration, we do this by using the pipette. So see, in the upcoming parts, examiner is going to ask you that what is the mistake or how we can make it accurate. So instead of using measuring cylinder, we will use a pipette because that is the proper way. And why the reason is that pipette measure accurate volume and measuring cylinder measure or record, approximate volume. Stand the conical flask on the white tile, okay, for the visibility purpose. Slowly add solution A from the burette to the conical flask while swirling the flask until the mixture in the conical flask just starts to become cloudy. Record the final burette reading. Okay. I hope the things are clear to you guys. Okay. Now experiment 2. Empty the conical flask and rinse it with distilled water. Empty the burette and rinse it with distilled water. Rinse the burette with solution B. Repeat experiment 1 using solution B instead of solution A. Okay. Use the burette diagrams, figure 2.1 and 2.2 to complete the table 2.1. Okay. So that is for experiment 1 and that is for experiment 2. Okay. So with experiment 1, the final burette reading is, if you guys see, it's 18.3 and the initial burette reading is 0.7, right? No, 0.6. Yes, 1 minute. Okay, Mustafa, in titration, we use the pipette for transferring the volume into the conical flask. It is because the pipette measure the volume accurately, but instead they have used, measuring cylinder over here, if you see. So measuring cylinder is basically record the volume approximately. So see, in the upcoming parts, examiner for sure is going to ask you about this, that how can we improve the method. And in the same way, I am sure that examiner ask about the white tile as well, because here it is mentioned. So why we use the white tile? We use it to observe the color change clearly. Okay. So when we take the difference, we are able to calculate the value. So 13 minus 6 gives me 7. And it becomes 17. So 17.7. Okay. Now, for experiment 2, the initial is 9.2 and the final is 21, right? So the final burette rating is 21.0. Do remember, if it's 21, you just don't write 21, you have to put one decimal place. And it was 9.2. So when you subtract it, you will get 8 and 20. 20 minus 9, 11. 11.8. So these are the volume. Okay. So see, explain why a white tile is used during that titration. To see the color change easily. Okay. See over here, it's 0.6 and it's 18.3. Okay, Waleed, for experiment 1. Okay, C part. In experiment 2, the burette and the conical flask are both rinsed with water. Okay. The burette is then rinsed with solution B. State why both the burette and the conical flask are rinsed with water. So, because in both there is a initial solution that the solution was A, solution A, and now we are going to fill solution B. So, it is to clean them and to remove solution A. Is this understandable to all of you? Now, explain why the burette is then rinsed with solution B. So see, burette is initially washed with the water. Now there is the water in it. After washing it, there is some water in it, right? If we just fill the solution B in it, what will happen that the solution B gets diluted, right? So we rinse it with the solution B to remove the water from the burette. Now, after that, when we will get fill solution B, so it will be all solution B and it will not get diluted. So to remove water from it. Is this understandable to all of you? Now, third part, describe how the result of experiment would be different if the conical flask is rinsed with aqueous ammonia after rinsing with the water. Okay, because see, in conical flask, we are not measuring it, right? So we are measuring in the burette and then transferring in the conical flask. This kind of the reason we have been discussed earlier as well. So if we rinse it with the ammonia, so some of the ammonia is left behind. And then I fill the pipette and transfer the ammonia in it. So we have a more ammonia in it, right? Now it has more aqueous ammonia in it because we have rinsed with the aqueous ammonia and then we have transferred the aqueous ammonia. Because now, okay, no, that's fine. And if it has a more ammonia, now more of solution B is needed to neutralize it, right? Okay. Now, B1, reduce which solution of copper to sulfate A or B is more concentrated. Explain your answer. Yes, which one is more concentrated? If you look for solution B, we need a lesser volume of aqueous copper 2 sulfate, right? So it indicates that it's more concentrated, because it is, if it's diluted, then we need the more amount of the other one as well. For A, 17.7 centimeter cube of aqueous ammonia has been used, right? And for B, 11.8 centimeter cube of ammonia has been used. But the thing is that which solution of copper 2 sulfate, A or B, is more concentrated? Explain your answer. So it means that solution B, no, Umar, no question from the equilibrium, is more concentrated as lesser volume was needed. If anyone has any doubt in this, please ask. Okay, see, are we changing the concentration of aqueous ammonia? No, right? In this, we have aqueous ammonia, and in this, we have aqueous ammonia. Here we are adding solution A, and solution A 17.7 centimeter cube volume has been consumed. And here we are adding solution B, and just 11.8 centimeter cube of solution B's volume is consumed, because the concentration of these two are same. So their concentrations are different. So see, if this B has a lesser volume is needed to neutralize it, it means that in this lesser volume, it has a more number of moles in it. Is this understandable, Oliver? So that's why B becomes more concentrated. Now, part 2. Reduce how many times more concentrated this solution of copper 2 sulfate is than the other solution of copper 2 sulfate. Okay. So you just take the ratio, you will identify that by which factor they are changing. No, concentration and volume are inversely proportional, Waleed. So just check the ratio. 17.7 over 11.8. What ratio you are getting? No. We have to identify how much more it is concentrated. So it's about times that how much more it is concentrated. So that's why we divide it to get the factor by which their volume are getting changed. So it means that it is concentrated 1.5 times more than the solution A. Describe how the reliability of the results obtained can be checked. So the reliability, it means that are the results reproducible or not, or all the results consistent or not. And for that, we have to repeat the experiment and then compare the results, compare the readings. So repeat the experiment and then compare the results. If the results are closer, the readings are closer, it means that the results are reliable or consistent. Part F. Reduce the volume of solution A required when experiment 1 is carried out with 10 centimeter cube of aqueous ammonia. Okay. So here it has been carried out with 25 centimeter cube of aqueous ammonia, right? So with 25 centimeter cube, we need 17.7 centimeter cube of A, right? That is ammonia and that is A. So if 10 centimeter cube of ammonia is being used, so how much volume of A is needed? That is X. So can anyone calculate the value of X? X is equals to 17.7 times 10 over 25. It's 7.08, right? So you can round it off to 7.1. So we did the working that for 25 centimeter cube, 17.7 has been introduced. For 10 centimeter cube, X. So X is 10 times 17.7 over 25. It will give me 7.08, which is being round off to 7.1. Yeah, it's necessary. Do show your working. G part. In experiment 1 and 2, the volume of aqueous ammonia is measured using a measuring cylinder. Okay. Given advantage and a disadvantage using a volumetric pipette instead of a measuring cylinder to measure the volume of aqueous ammonia. So what is the advantage? It's more accurate, right? And what is the disadvantage? The process becomes slower. It takes time. No, not less volume at a time. We are using 25 centimeter cube, whether we are using the cylinder or whether we are using the pipette. But when we use the pipette, the time will be elongated. It takes more time to complete the experiment because you have to fill it slowly and gradually till the mark. And then you have to, transfer it in the flask and you have to wait until all the pipette will be drained. So that takes time. Okay, is this clear to all of you? Now we have to start question number 3. A student tests two solids, solid E and F. Okay. Test on solid E. So you are given with the table. You can compare with the table and then identify the things. Gently heat half solid E in the boiling tube. A solution forms. Steam is given off and condensation form at the top of the tube. So see, this is very important. See, steam is given off. It means water has been released, right? So if the water has been released, it means that E is hydrated. It has a water of crystallization in it, and that's what they have escaped and then condensed on the top of the tube. Is this understandable? So it means whatever the formula of E is, but after that formula, it contains X moles of H2O that we don't know right now. Okay. Now, dissolve the remaining solid E in water to form solution E. Divide solution E into 3 portions. To the first portion of solution E, add aqueous sodium hydroxide dropwise, then in excess. A brown precipitate forms which remains excesses when excess is added. So what are those brown precipitates? Yes, very good, Umar and Ahmed. So there is a possibility that it contains iron 3 positive ion. Okay, warm the product of the test tube and test any gas produced. Gas turns lime red, litmus blue. So it means ammonia gas has been released, and if ammonia gas has been released, then it means that it also contains ammonium ion in it. Yes, very good, Umar. To the second portion, test 4. To the second portion of the solution, he add 1 centimeter cube depth of dilute nitric acid followed by few drops of aqueous silver nitrate. No change. So dilute silver nitrate, so it means that no halide ion is there, no chloride, no bromide, no iodide. Third portion of solution, he add 1 centimeter cube dilute depth of dilute nitric acid followed by a few drops of aqueous barium nitrate, white precipitates, which indicates that sulfate ions are there. Is this clear? Okay. State what conclusion can be made about solid E from the observation in test 1. So in test 1, we can identify that, yeah, that is the test 1. So E is hydrated compound or E contains water in it. Identify the gas produced in test 3. So we have identified the gas, that is the ammonia gas, right? State what conclusion can be made about solid E from the observation in test 4. So in test 4, there is no chloride, bromide, or iodide. E does not contain chloride, bromide, or iodide. Is this clear? Now, B part, identify 3 ions in solid E. So we have identified there is a ammonium ion, there is a iron 3 positive ion, and sulfate ion. Is this understandable to all of you? Okay. Test on solid F. Solid F is zinc sulfide. So it means ZnSO3. Complete the expected observation. The student dissolves solid F in water to form solution F. The student divides the solution F into 3 portions. To the first portion of solution F, the student adds aqueous ammonia dropwise until it is in excess. Observation. So with a with the zinc, you are going to get white precipitates and they dissolve to form a colorless solution. When we have added in excess, dissolves to form colorless solution. See, you can get it this from over here. They have told you that it's a zinc and aqueous ammonia has been added. White precipitate soluble in excess, giving a colorless solution. Okay. So we are going to write these observations over here. Now, F part. To a second portion of solution F, the student adds a few drops of acidified aqueous potassium manganate. Okay. So, observation. So it's a sulfide over here, SO3 2 negative, which can be oxidized to sulfate. Okay. And potassium manganate decolorizes. And if you will see this over here for sulfide, right? Add a small volume of acidified. What will be the observation? Changes color from purple to colorless. Very good. So I am going to write over here observation purple to colorless. To a third portion of solution F, the student adds 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous barium nitrate. Okay. As they have told you, sulfide. So sulfide does not show white precipitates over here. No change. Yes, very good, Umar. With the sulfate, we get the white precipitates. With the sulfide, we want. Okay, it's clear to all of you. Now the next question, the 6 marks question, and that's you, the one which in which you are going to face problem, but I think if you guys practice, then you can attempt it somehow. Solid cobalt 2 oxide is a base which is insoluble in water. So see, they have told you it's cobalt oxide. It's a base insoluble in water very slowly with cold dilute sulfuric acid to form a solution of cobalt 2 sulfate. Describe how to make a pure dry crystals of hydrated cobalt 2 sulfate. You are provided with cobalt 2 oxide, dilute sulfuric acid, and common laboratory apparatus. So see, here they have asked you the complete, preparatory method of the salt that you have been studied in for paper 2. No, it's a insoluble in water. So precipitation method, why crystallization and why excess solid? These are for when the salt is water soluble salt, isn't it? The excess solid method with the acid or the crystallization, these all both are with the when the salt are soluble. It's not soluble, it's insoluble salt. No, sorry. Basically, they are saying my comprehension is bad over here. Cobalt 2 oxide is a base which is water insoluble. Yes, Aisha, very good. So we do with the excess solid method and the cobalt solution of cobalt 2 sulfate. So the salt we are getting is a water soluble salt. Okay. So if you see, when we react cobalt oxide with the sulfuric acid, so see, it's a solid because it is water insoluble. And they told you that you are going to get cobalt sulfate solution. So it means it is going to be aqueous, right? And water. So it means acid with the excess solid, that method we are going to use. So see, you have to explain that method. So add excess cobalt to oxide in a container having then we'll do the precipitation method where we use two aqueous solutions, and when we mix it, we will get the precipitate. We will filter the precipitate, wash it with the organic solvent, and then dry. Add excess cobalt 2 oxide in a container having sulfuric acid. Okay. Then stir the mixture. And why we stir it? To make it dissolve quickly, because as they say that it reacts very slowly with the cold dilute sulfuric acid. And warm. So when we warm it or heat it, what will happen? That it will dissolve more readily, more quickly, okay? After solid stop dissolving, filter the excess solid, then heat the filtrate till crystallization point, then leave it to cool. After cooling, filter the crystals and then try using filter paper, or instead you can write try using a dry oven. Okay, so here we are done with the method and we are done with the paper as well. So you see, if you guys see, I think we have done it in 30 minutes, the whole paper. And if you look at the timing, they have given you 1 hour. So if you do a practice, I think you guys can able to attempt in 40 to 45 minutes. Yes, in this question, there are no moles. There are very less moles, but moles usually come with the titration. But here with the titration, they have just gave you these things and just a very simple calculation over here. So you might get calculations and moles. There is a high chance. Do remember that, okay? Okay. So we are going to do one more paper tomorrow, inshallah. Okay. And one more thing.